the first demo we're going to show you is the scanner application. We've got a Zebra scanner here, and you'll see it's, I think you can see, yep, it's connected on Celona LTE. It's a Windows-based tablet, and we're going to fire up gping, and we're connecting to our host, the host IP that we put into the application, 1048.130, I think, from memory. Is that right? 3130. There you go. And you can see we're maintaining sort of sub 30, around about 35 milliseconds ping right now. And unless anyone is doing anything via the staff hotspot, that's continuing on. There's no other traffic on the network. So yeah, great. We've got a 150 by 26. Nothing else is happening. We just have a single AP, nothing going on. Now, in the other window, we've got an iPerf session we're about to start. We've got some iPerf. I've got another little nuke there running Proxmox virtualization. We've got 4 iPerf servers running on there, and we're just about to set up an iPerf. And what we hope to see is we'll see a little bit of jump in the latency, but essentially it should go straight back down and maintain that sort of around about 35 to 40 milliseconds latency, regardless of what's happening with that. Regardless of what's happening with the iPerf traffic. And you know, if anyone wants to, who's already connected to the M2000? Who's
running speed tests on it now.
Oh, you're already running speed tests? Oh, thank you. So someone's already trying to mess around with our network in the face and make sure our micro slicing is working. So the staff IP domain, that natted IP domain, that traffic is going through here. There's people running speed tests, and we're still maintaining our micro slice performance. And if there are iPerf servers on 10, 48, 31, 31, 32, and 33, if you want to run any other tests, and feel free, because that's not going to change. The micro slicing policy will maintain predictable performance for that scanner application. That traffic is protected regardless of whatever else is happening on the network. And you can see we're pulling 42 meg down on that iPerf because there's some other traffic going on the network, and we're still keeping, yep, we're actually averaging around about still that 36 milliseconds.
JR, a lot of us in the room and the audience understand how Wi-Fi does the prioritization in QoS.
Mm-hmm.
Can you explain a little of the technology behind how microslicing is accomplishing this, that you can dedicate this?
Sure. So what's happening technically here is when Celona Edge sees the application profile that we've created. So for the device group, the scanner device group, so it sees the device and says, okay, that device is a scanner device. I know that because that's that device group. Great. And the application is traffic going to 1048.31.30. Ooh, that's that traffic. Right. I need to create a dedicated bearer between that device and the AP and the edge. So, but the critical part is the dedicated bearer between the scanner and the AP. So over the air, that is protected. So because we're TDD, again, that bearer, that's yours for your application, protected. That's how it's doing it, essentially.
So is that something that could be possible with Wi-Fi 6 with OFDMA if they had programmed it that way?
It's possible, and there is some capability within Wi-Fi 6 because of the enhanced capability for control channels, but it doesn't have the level of sophistication that the control channels have in private cellular, in cellular technology.
So that little pipe that you dedicated, it's like nothing else is going over there.
No, nothing. That dedicated bearer is dedicated to that application, to that device. So there is, you know, there could be contention in the air, but because in Wi-Fi, because it's Wi-Fi, but because we're licensed spectrum, and because we're TDD, that is what it is. And like I say, that is built into the spec right now today. So it's the way I like to think of it. There's a lot of like private cellular versus Wi-Fi. Like, I think Tom Carpenter said something very. We can't keep asking Wi-Fi to do everything. And it's, like I said before, what do you do? I swear I spent 20 years fighting physics. I open the toolbox and all I got is a hammer. Well, now I've got a scalpel. I can start to do some more cool stuff. And I think it's not either or. It's I've got Wi-Fi, I've got LoRaWAN, I've got Bluetooth, I've got the private cellular just slots in somewhere for some particular applications and purposes, and whatever else. It's a tool. I always try and avoid the versus argument. It's more a case of, no, we've got another cool tool. And in a lot of cases, what I find talking to people who've been involved in wireless for a long time, it's like a lot of the things we thought we could do with Wi-Fi early on that we got really excited about in the early 2000s. And we're like, oh yeah, we can do robots and we can do all this stuff. And then we found out afterwards, like, yeah, it kind of doesn't work. We can do it now. But Wi-Fi is not going anywhere and shouldn't.
Thanks.
All right. So that's our latency demo. We've protected that traffic. We'll leave that running because that can just stay and keep running. And Kevin's going to put that picture in picture. And now we'll do our AMR demo. And this is where you might get you dancing again, Tom, because we need to have lots of movement in the camera to keep the bit rate going.
Question for you. So if you deploy and we're in a warehouse environment and talking about like automated robots and things like that. If the experience is poor for whatever reason, right? Like the racks are so dense, the design is off, whatever happens. What do you do from a troubleshooting standpoint currently? Because there's not Ekahau for CDRS yet or anything.
Yeah, that's a really good question. There are more tools coming out all the time. One I mentioned, the Epic Prism scanner, which is a little backpack device. EPIQ Prism scanner. It's an American manufacturer. It'll work with it's USB-C, so most Android phones and then iOS tablets. Can we have an iPhone with USB-C, please? That gives you a full spectrum analyzer on a handheld device, which starts getting us towards where we're at with Wi-Fi. With some portable devices, there's also I think Qualipoc is another sort of handheld device where you're going around and you're doing very similar things that you're doing with current Wi-Fi spectrum analysis tools. So they do exist. They're slightly more expensive right now, but they're coming down. We're getting more predictive tools. So Hamina Wireless, their indoor platform, we've seen some really cool stuff that they're doing. IBWave, we've done a lot of work with IBWave. All of our APs are already populated in the IBWave platform for planning. And if there is an issue, we go in and we use these spectrum analysis tools and we do measurements. So in these environments where we have got moving devices, and we've done exactly this. At the early stages where there are these robotics companies who we've got robots moving at up to 30 miles an hour in a caged, no humans environment. Moving product around a controlled space, and they're stopping because there's a handover issue and you have to shut the whole thing down. Yeah, then we're going in and we're figuring out exactly where there's a coverage gap and tuning handover and things like that. So yes, those tools do exist. Yeah, we're working with resellers and partners to share
the public, I guess, if you will, or the consumers of it know too, right? Because we are asking for like your most valuable use cases, right? So being able to troubleshoot them and being able to make sure that while the technology can provide latency and bandwidth allocation and those types of things, a poor design is going to destroy all that, right?
Absolutely. Yeah.
So being able to troubleshoot a problematic design is absolutely critical, I would think.
And that's, and we see that at Celona. You'll notice that we're working with a lot of other different partners. We're doing webinars with IBWave, and we're working with Hermina, and we're working with everyone in the whole space to, bring up the level of all, a lot of us came up through Wi-Fi and, building cantennas and doing war driving and doing all those things early on. And we didn't have those tools at the beginning either. So we know what needs to come through, and we're working on making that happen.
What's your perspective on a network sensor? Do you think you'll need that for any of your deployments?
Network sensing?
Network sensors, like having something.
That validates?
7-signal.
Yeah. So actually, there's some that you can get now that people were using for validating macro networks. So there's one which we've used called NPerf Fleet. So I switched from speedtest.net to NPerf, which is a French manufacturer, French vendor.
Yeah.
NPerf, N for November. And they have an automated tool called NPerf Fleet, which you can load on handsets, and you just drop them in the customer's network and leave them there, and they'll perform tests on a regular basis. You can set it to do latency, speed test, and you can also set it to load specific websites. Set a whole set of scripts that will perform on an hourly basis and keep a record of all of that for you. So those things exist currently.
You can do video streaming.
Yeah.
So,
yeah, you can set it to pull YouTube. You can set it to pull all kinds of things.
Yeah. I understand Celona has a gateway that I can connect non-cellular devices.
Mm-hmm.
Right?
Yep.
Can you? So has that actually been deployed in some of your deployments? Can you talk about that?
Yes. Obviously, there are some devices that are existing in the network that don't have CBRS capability. CBRS band 48 is not on many existing cellular devices, older ones. It's iPhone 11 and newer, Samsung S10 and newer, Google Pixel 4 and newer, to give you an idea. So like 3 years basically of history of modems. So anything older than that basically doesn't have it. And then there's a whole bunch of other stuff that just doesn't have cellular modems, like tablets and laptops and all those kind of things. So there's a whole range of different Wi-Fi and Ethernet to CBRS devices. And that's everything from USB-C modem, this little bad boy here, and to hotspots, to this is the Cradlepoint R500 private LTE gateway, which they released specifically for CBRS, small, rugged, 2 ports of Ethernet and Wi-Fi, in vehicle for home use. There was a lot of work done on smaller, low-cost devices for fixed wireless access for K-12 early on during the pandemic. So there's a bunch of those out there as well. They tend to have 2.4 Wi-Fi in for some reason, but they do. But these, have got things like AC and support all the Wi-Fi authentication and those kind of things if you want to back it off. But there's, as we mentioned before, if you go to Celona.io, look at our documentation portal, there's a whole list of different devices that can do that Ethernet to CBRS and Wi-Fi to CBRS.
So if we currently have a Wi-Fi deployment, but we see a need to kind of, for some applications to have the quality of service, right? Those same devices could connect onto a 5G network. So we could deploy a 5G network and not have to change all of our user devices.
That's right.
Right?
Yeah.
So that's an important thing to realize. Right.
Yeah. There's a migration path that you can take. There's no need to sort of wholesale just replace everything all in one go. So for example, if you've got devices on a forklift or a bus or whatever it might be, that you need to bridge that gap. Yes, there is a device that can do that. You don't have to replace everything that's there. You just are replacing one device, not everything. All right, we'll do the video part of the AMR demo. So you'll see we down in the picture-in-picture, we've got our latency demo is still going and our iPerf is still going on that one. We're maintaining that slice.
What was that iPerf server address again?
We've got, so 1048, 31, 1048, 31, 31, 32, 33. We've got another 3 running. I'm not sure which one are you using, Kevin? 30?
31. Yeah, 4 servers.
Okay. So yeah, so our iPerf servers are 30, 31, 32, 33. Use any of those. Okay, so you can use 33 and 34. Okay, so you can see on our Axis camera, we've got some bitrate information. We've got an overlay here that's telling you how much frame rate we've come through. And you remember from our micro slice, we set a variable bitrate. We didn't do guaranteed bitrate on this one. We set variable. But we wanted to make sure that whatever happened, that would be protected. We didn't say, well, it has to be this much, because on something like an AMR, there's going to be various different applications coming from that device. There's going to be low bitrate sensing, things like location, and there's going to be high bitrate computer vision happening, to make sure it doesn't do things like run into me if I step in its path. And that needs they all need low latency, but you can see when I move, that's going to go to there you go, 4 megasecond. And I need to make sure that that's happening and doesn't have an issue on the network. And that's maintained, and our frame rate is maintained at 30 frames per second. We're not going to drop any of those. Sorry, I'm moving so that we get good bit rate coming through, and it's keeping it around about 3-4 megasecond. And you'll see, keeping that 30 frames a second, keeping that bit rate, doesn't matter what else is happening on the network, because our micro slicing policy is maintaining that. And if we quickly flick to the orchestrator view, Kevin, we should be able to see that those slices are performing. We should see some micro slicing metrics. So you asked before about, how do we know that things are actually happening, that the network is doing what it's supposed to be doing? You're getting metrics on everything that's happening, and we're giving you some feedback on that. And if you go to the actual micro slicing section, Kevin, and click into the specific slices, so go to the micro slices. And if you click on AMR, there we go. We should see, there you go. So you're seeing that we're getting throughput there, hitting up to 3.5 megasecond, which is what you'd expect for 1080p, 30 frames per second, MPEG-4 video, right? So up to 4 megasecond. We did actually set a maximum bit rate on the camera of 4 meg, which is standard practice for cameras to stop them going crazy when they go in the dark. You can see throughput, you can hit latency, and you can see what our typical round trip time latency. Our target on the slice was, you'll see here, 100 milliseconds was our target. Less than that, we're maintaining that. And if we scroll down, there should be a little bit more information. We can see sessions, top talkers, a little bit more information there. So that's how you can validate that slices are working how they should be. And as we showed before, you can go into an actual device as well. So
those applications marked as guaranteed bitrate?
Yeah, the guaranteed bitrate, if we go into the scanners one, Kevin, that was set as guaranteed. So we set, I think, 100 kilobits per second guaranteed minimum bitrate and 1,000 maximum. So 1 meg maximum for that. So if you do have applications that require guaranteed bitrate, we can set that also. And you can see, session counts. And if we go to latency on that one, Kevin, it should reflect the latency we were able to achieve. Not refreshing. Okay. We mentioned earlier that this is our interface to the API, the orchestrator API. And Kevin has done a little bit of work in the background while I've been chatting away, and set up another dashboard just to pull some data from our API. And this is real-time data acquired using the API key, and Kevin will show you how where we get the API keys from the orchestrator dashboard. And you can see that we've got 4 devices up, 1 edge node up, an AP up, and 5 devices total activated. But you see there, we've got I think our blue line is our APs up, and the top line is our devices up. And we can start adding some more probably. If anyone wants a SIM for their phone, anyone got an iPhone or any of the newer phones that we mentioned? There we go. And well, I'll need to know what the last 4 digits of the ID is, so that I can enable it for you. Actually, there you go. And if anyone has a USB-C and wants to connect to the scanner network, so we're gonna. I think what we'll show is a bulk activation, Kevin. If we go into
do it. All right. I'm going to go to the device list.
So we go to device list, and you asked about the bulk activation before. And if we filter by not activated, so if we go device status and provisioned, so these are all the ones that haven't been activated yet. And we're just going to activate them all into actually, Kevin, should we assign them all to staff?
Sure. Yeah. Let me do that now.
So let's assign them all to staff.
Not activated yet.
And then we'll activate them all in one go. There we go.
So what do we need to do from our side?
You don't have to do anything.
Oh,
just give it a couple of seconds, and those have just been activated. So within about 5 seconds, you might need to do an airplane in and out in a few moments, and we give it about 10 seconds or so. You'll be able to do airplane in and out maybe, and you should be able to connect.
Actually, while I do this, I'll skip over to the scanner tablet again.
Yeah.
And see kind of the data while everyone joins.
While everyone's doing that, you can see our scanner application is still happily chugging away at 35 milliseconds average.
Oh,
yes.
Are you seeing any phones that are doing
oh, my VPN
dual
even.
SIM that are supporting yours plus like a carrier card? That
Yep.
other ones you recommend?
So at the moment, the only phones that really support dual active SIM is iOS. So there are dual SIM phones on Android, but it's either or. There's one is active at a time. With iPhones, they will have, I've had often my iPhone, I'll have my eSIM active on my private network at home and my physical SIM, my Verizon SIM at the same time. Be warned, choose battery like you wouldn't believe.
You're right too.
If you're running 2.
Is that because one's like searching if you're not using it or something?
It's just you have got 2 radios running. So it really does go through battery pretty fast. So that's something I think that they're working on to make it more efficient. But right now it does use quite a lot of battery. But over time, I'm sure that'll become more efficient.
What about the vSIMs? Are you seeing any virtual SIMs?
No, that is using eSIM. So I'm using eSIM for Celona, and then physical SIM for Verizon. But I could do either one. I've done both actually. I've done the eSIM AT&T and physical SIM Celona in a phone as well.
You know what phones will start at on the iOS?
Sorry.
What do you know? What phone?
I've done it with my iPhone SE.
You're on the way.
Yeah.
Yeah.
iPads as well. They support eSIM.
That.
So yeah, iPhone SE 2020.
And then I'll do this.
The first one, I think they're the sort of lowest end, about $350 now.
Yeah, 11 and up. Yeah.
That was amazingly simple.
Yeah, we see now, if we look at the device list, we're seeing some people connecting on the 172 network. And
You need our MAC address or the EMI, something off the SIM.
no, we just activated all of them. You can, we just activated bulk activated all of them in one go. So you'll all be connected. I mean, I could have asked for something really sensitive, couldn't I? But we just decided to bulk activate you. It was easier.
Can you give staff a bigger micro slice?
Well, we could create an application for staff right now. We could set up Zoom on staff, for example. We could create an application right now. We can create an application for speed test. we could do that in a couple of moments and have a custom application running for all your phones.
It's brilliant that these guys that would never probably connect to a public hotspot are all very comfortable
Yeah.
with cellular because, you know, the inherent belief in the security, right? The SIM, yeah.
Yeah.
I'm just pointing it out.
JR, that's, that's we know where to find it.
And you know, it's the British accent. It's inherently trustworthy.
It's either trustworthy or Bond villain.
Yeah, exactly.
Security, like paranoid people counterfeiting something like this and getting it on a system.
No,
Difficult.
no.
Difficult. Impossible.
Everything difficult to impossible. I mean, again, we're benefiting from 15 years of mobile standard. That's encrypted. When you put that in, that is encrypted connection between your phone and there. There's encrypted between the AP and the edge. There is an encryption chip on the AP. So it is versus security in the Wi-Fi world, you are 10x easily.
Are we being rate limited on this? Because when I connected through your little hotspot, I was getting way faster than when I put the SIM in.
So I think there's a lot of people running iPerf. So we're on a single AP. So our total available bit rate is 150 by 26. So if there's a bunch of people running at iPerf and I gave you all the addresses, then you know that's that's what we have.
And then, unless I'm wrong, we're also going out the hotel connection, which
Yes.
is not.
Oh,
Yeah.
Yeah. So the internet, I don't know what the internet bandwidth is, but locally you've got 150 by
enough.
26. So I mean, summarizing, really, we built. Our goal today was to come here and show you just how easy it was to build a network from scratch, a private cellular network, and thank you. Good. You know, the major things, as I said at the beginning, you can get started with private cellular today. So at Celona, from the very beginning, our goal has been to enable as many enterprises and users as possible to be able to deploy private cellular networks. That's what we want. I have been trying to deploy cellular technology in networks since 2009. And so as soon as I was able to do it, I was, couldn't wait to get my hands on it. And so it's wonderful to be able to do it. And that's our reason for being at Celona, is to make that technology available to as many of you as possible. You can get started with private cellular right now. There's no reason to wait. We've removed all of those friction points. You can do it right now. Managing private cellular is absolutely within your capability. There is no reason that you cannot do that today. And there are issues, there are challenges, there are applications that require a private cellular solution in your network that can help you solve problems that you might have today in your network. So have a think about what some of those might be, what some problems some knotty issues that maybe it's like, just can't address that yet. Just don't have the tools. I'm waiting for this, I'm waiting for that. Private cellular might be an answer to that right now. And like I said, it's available today. You can do it right now. So I hope we've achieved those three messages. And if anyone has any questions, you can go to celona.io/start and start your Celona product journey there. And if you'd like to join myself and Kevin and the rest of the newly minted cellular nerds at the frequency community, you can go to frequency.celona.io. And on LinkedIn, please do subscribe to the Daily Pulse, my private cellular networking newsletter.